Hello YouTube, De-bodgery here. Welcome to EV Components Review. On the bench is the KO Moto Rush controller, and this is the second half of the overview video. We're going to talk about the two power stages. So here's the middle power stage, here's the main power stage. So let's talk about this one first. In fact, I'm going to lean this one up on the side of the shell because they are virtually identical in every way. That matters. So the first thing I want to mention is this. Yep, that stud was soldered down right there. However, somebody at the KO Moto factory cranked on the screw that goes in here so tight that they sheared this off. They did it. This isn't the screw. It's here in my pile somewheres over to the right, of which you can see some of the pieces right there. But the head of the screw is cammed out because they cranked on it so hard. And they literally twisted this off the board. Yep, KO Moto did that, not me. I just opened up the controller and carefully lifted this power stage off of all these studs and found it that way. So yeah, good job KO Moto. You failed right off the bat. Gotta wonder how many more of these controllers where you have sheared off these skinny little studs, because these ones are prone to the same thing. I don't want to squeeze on these very much because I'll probably pop them loose or rip up the traces, but all I can say is, wow, good job KO Moto. Another cheap aspect is heat shrink around these things so that this brass can't short against the aluminum on the underside of here. How cheap can you go, KO Moto? Yeah. That's pretty cheap. You got to use heat shrink. That's the best plan of attack you have here, is heat shrink. Alright, so let me set this stud aside. I can solder that back down. I can. Most of you can't. But I gotta wonder how many other controllers out there have sheared off studs, because I'm probably not the only one. All I can say is, oh my God! Holy cow! I cannot believe that this happened. Alright. Set that aside. Okay, so if you look at these two power stages, they should look super familiar to you, and that's because these are almost exactly, in every way possible, identical to the Pro/F-Spec power stages. The only thing that's different is some additional copper that is done better in some ways and half-assed in some others. But otherwise, yeah, there is literally no redesign work hardly at all in here. So when Chris has said things like, we took this thing top to bottom, back to school, we've been super busy doing redesign, he is lying to you. There is almost no redesign work here at all. Literally almost none whatsoever. Alright, so here's your main power stage. This one's got plenty of thermal paste on it. It's secured fairly well to the heatsink, aka the shell. So that one's going to have a pretty good thermal path. Of course, as is usual for KO Moto, they still have this really awful layout. And so all the MOSFETs are across the top side, rather than distributed evenly across the metal core printed circuit board so they can radiate heat best. If they were done that way, these MOSFETs could actually be driven much harder. It's already well known and established that you really can't get more than about 600 phase amps out of here because, well, the MOSFETs overheat, this board gets hot, and then the controller starts throttling. Yeah, that's a design flaw. That is not the MOSFETs. These MOSFETs, 4 in parallel, like that, that is good for 1,920 amps max. 1,920 amps max. Go look at the KO Moto Pro, KO Moto F-Spec, Rush data sheets, or specs and stuff, and show me where they say 1,920 amps. Show me where it is. It's not there. But that's the maximum limit for this exact model of MOSFET. That's the maximum limit for those MOSFETs. 4 in parallel, 1,920 amps. And in this controller, in the Rush, you have 8 of them in parallel, or 3,840 amps. 3,840 amps. 8 of these MOSFETs in parallel their maximum limits are 3,840 amps. Do you know how much amperage a Tesla Plaid uses? It's not 1,900 amps, it's about half of that. So why you think you need 3,840 amps on a Suron is the dumbest thing I've ever heard. You don't need anywhere near that amperage, not even close. So this second power stage, the second 48 MOSFETs, is stupid on every possible level. And it's an absolute waste of money. It's extra cost that is not needed in any way, shape, or form. So if you want to actually beat EBMX KO Moto, A, redesign your power stage, right? Copy what EBMX has gotten from CYC. Copy it, almost exactly copy it. And then fix a few things that they don't have in there, which are pretty small. So copy their power stage, all right? All that copper, all that stuff. But use your MOSFETs, because your MOSFETs are actually 479 amps each, and theirs are 380 amps. Yeah, and so they get 1,900 amps max out of 5 of them in parallel, and you get 1,920 with 4 of them in parallel. So you already have the more powerful MOSFET, you're just not using them because you can't. Your board overheats before your MOSFETs get close to the limit. You don't need 48 MOSFETs. You need to use the 24 you already have and use them well, and you are not. So, yeah, that's a totally separate issue. You're not driving them right. Your driving times for the gates are too long because you can't efficiently turn them on and off quickly enough. That's a problem. That's why they overheat too. You know, super lossy design here. Yeah, everything about your design sucks. Everything about the EBMX design is so much better in every way. It's way more efficient. And yeah, they can run much closer to their limits than you can. I already know of people that are seeing 1,000 amps on their X9000s, which you can't ever do on an F-spec, at least not without a burning out. And you do 1,000 amps on here? Maybe. Yep, and I can tell you this much, if you put a water block on an X9000, you're going to be able to go a lot above 1,000 amps. I'm going to say 1,300 amps, no problem. 1,300 amps. And that's with 5 MOSFETs in parallel, not 8 like you got. And they still won't run hot. I know of people that run 800 phase amps all day long on their X9000, and their controllers get up to like 120 degrees Fahrenheit. And, well, you can't do that. The F-spec or Pro controllers, you try running 800 phase amps on them, they shut off and burn out. Because it's already been well established that 600 phase amps is about all you can really get out of one without them overheating. Because this is a super lossy design. All right, so let's talk about what you did better than you did before. Because there are a couple things and, yeah, a bunch of stuff that's still just as crappy as ever. Okay, so you have this big piece of copper here. And I can look under this piece of plastic and I can see that it does actually solder to the stud. It actually curves around it and there's solder to it, so that's good. Same thing for this one to that stud. So that's an improvement. And as you can see here, this piece of copper does solder down there, and this piece of copper does solder down there. So good. You know, it's not like before with the Pro and the S-spec where you just use little scraps of strap and stuff and kind of bodged it together. You know, this is like purposely built to curve around this connector, which, by the way, these are rather expensive. They actually do work quite well. They are very high current and very reliable, very low internal resistance. So these are actually pretty good connectors. But again, this entire power stage is completely extraneous and useless and pointless and shouldn't exist. So, yeah, these two buses are much improved over the way they were before. And you do have these combs in here that reinforce those phase buses. Your copper bridges are improved, so that's better too. Thing is, though, is like your bridges are now a new failure point in a different way than they were before. The old bridges, because they were made out of, you know, a spool of copper strapping, they could actually flex. So this section that was down here, that part was always going to be okay, and all the flexing would happen up there, or all the rotation on the solder would happen up there, and that's where it would break. With these ones, you have no flex in here at all, none. So copper expands, copper contracts with heating and cooling. Those are, how things work with all metals and all materials. And these ones are going to expand and contract, and they're going to stress the solder on the tops and the bottoms of both of these bars. Same thing here. This are here and here and here and here. So rather than stressing one solder joint like it is on the Pro and the F-Spec, now you're going to stress both ends. So the failure possibilities have gone up, not down. So this is a reliability issue that those solder joints on either end, and I can't tell you which one will fail first because that's totally luck of the draw, but because the copper is much stronger than the solder is, your solder joints on either end are going to fail, and the likelihood of them failing is equally high on either end. Just don't know which one will fail first. So, yeah, all they've done here is increased the reliability issues because there's no flex in here. Now they're totally stressing the solder on either end. So, yes, it does conduct current better, but it does it with the caveat of breaking solder joints more quickly. So I'm going to call that a fail. But this is typical KO Moto way. We don't think about what we're doing. We're just going to slap stuff together because people demanded copper. And we think they're morons, and so we're just going to slap it together and hope that they don't notice that we do shoddy work. But then there's people like me who have been dealing with electronics since the late 1970s who can look at stuff like this, and all I can do is shake my head and say, oh my God, what a giant storm of crap. All right, so this phase bus, this one, and this one are all reinforced. They got those little comb things in it. You can see that there is no copper reinforcing here at all the way over to the stud. There's no copper anywhere. So that bus is not reinforced in any way. And you can't see it so well down there, but the same thing there. That one is also not reinforced. So there you go. You can see it. There's no copper there. There is around the stud to strengthen that, but it doesn't improve the phase bus any. So this phase is still just as weak as it ever was. In fact, it's worse than it is on the Pro/F-Spec, because at least on those, right over here, you had a ring that could then connect up to the battery plus bus on the bottom of the logic board to reinforce the copper on here. And now these four MOSFETs, they're now swinging in the wind. They have no reinforcing over here at all, and that's true for this power stage and this one. So this is now worse for those four MOSFETs, and they were already weak, and they were already not reinforced anyway. So yeah, this is now going to suffer more than it ever has before. I already know this because I have photographs of it on the Pro/F-Spec controllers, of which that's effectively what you're looking at. This little piece of solder right here is what burns through when things go badly, and that's probably going to still be the case here. Yeah, and probably this piece of the circuit trace is probably going to do the same thing on these because it's still the same situation. You know, all they've done is kind of cram things together and shift stuff a little bit to make room for these studs. So this is in every way, shape, or form a Pro/F-Spec with some haphazardly placed copper and done poorly, because as you can see, you still have these gaps. This one is even worse, and the copper is even thinner, and you have even more gaps. So battery minus bus on both the center power stage and this power stage suck. They are terrible. They still suck. They've always sucked, and they continue to suck. Battery plus is still unreinforced, so yes, that continues to suck. This phase is still not reinforced, so that continues to suck as well. Yeah, let's look at one last detail here on this. So here is your middle power stage, and it does have this nice hunk of aluminum. I want to ask one question before I move on. Do you see any fins on there? I don't. So, Christopher said this is a heatsink. Do you see any fins on here? You already can tell because of its placement that this sits down inside there, completely surrounded. So it has no airflow over in any way, shape, or form. So by definition, this is not a heatsink. No fins, no airflow, no convective, anything happening here. This is called a heat spreader. So Chris, so that you look less like a fool, use the right terms. This is a heat spreader. It is not a heat sink. And yet you blabbed it out there on the Teleria KO Modders forum that this is a heat sink, and it is not. All right, you can probably see it. Yeah, sure you can. So this is a thumbprint on there. You can see it. So there's one there. There's another one right there. Those aren't my thumbprints, okay? When I opened this controller up, that smudge of a thumbprint, or two of them, was on here already. So basically somebody went with whatever they had on their hands and didn't even bother to clean it up. Anyway, yeah, good attention to detail, KO Moto, like usual. All right, so also I want you to notice another thing here. I have speculated that this needs to get heat from here through this board out to the fins to be able to keep cool. In which case I said that there was probably like a thermal gap filler across here or thermal potting between here and here. And there's not. There's literally nothing that transfers heat from here or to the shell. There's nothing. There could be some, and this would be better than the nothing that currently exists. So there's a shoulder right here, and this edge over here, and this edge right here, and there's another shoulder right here. They rest on that edge, on that shoulder right there. And that's acting as a spacer between this and this, is this shoulder. Otherwise, this is screwed down to there. So if KO Moto would have put thermal paste all in here on both sides, at least this thing would have had a thermal path across here and here to let heat out of this power stage. But because that is not the case, this is going to be able to get rid of heat very poorly. And it's still going to get rid of heat very poorly because it has no really good thermal path. Even through its edges, that's still not a very good one. It's just better than nothing that it's got right now. So what's going to happen here is this giant hunk of aluminum on here is just simply going to get warmer and warmer until it's finally heat soaked. And at that point in time, this power stage is going to burn up and die. Yep, that's how that's going to play because this has no way to get rid of heat. This one at least is slapped down onto the shell. And it has a direct thermal path out. This one has none whatsoever. So yes, it's even worse than I said before because I assumed that there was a thermal gap filler underneath here or thermal potting between the two, and that's not here. It's not here. Yeah, I said 5 to 10 degrees Celsius difference. I'm going to say 15 to 20 now because there is nothing here that can get rid of heat. This is going to just heat soak, and that's it. It does have a temp sensor on it, which is right there, so that's good. At least the controller will know that this thing is about to go thermonuclear and maybe shut things down. But still, this power stage is going to run a lot hotter than this one will. That's just how that works. Yeah, you just don't build this. And on the top of that, this is completely extra cost, extra design work that is wrong and extraneous and stupid in every possible way. Build this one right, and you don't need this. This is completely extra cost in every way. All I can say is, KO Moto, when you thought this was a good idea, what were you thinking? This is the dumbest thing you have done yet, by far. Well, I think that is everything I want to show between these two power stages. Kapton tape, stupid idea. Bridges that can't flex are going to break solder joints. Half-assing all of your copper reinforcing, just like you did on the S-Spec and the Pro. It's still all here. Of course, it didn't improve performance. Of course it couldn't because, well, battery plus is still weak. You still got a phase that's weak. You still got all these gaps in battery minus. Stupid, dumb, that's all this is. And KO Moto thinks you're morons and that you're too stupid to know that they just botched it together and don't care and just did it for show and pretend. And they think you're too stupid to recognize that something is good or bad. And this is bad. This is bad. Good grief. Well, I think that's it for this video. Hope to help some folks out. Don't buy Rush controllers, people. This is twice as bad as the F-Spec and the Pro controllers. Twice as bad. They should have never built this thing this way. Everything about this is just a bodge of bad designs and bad choices again and again and again.